H.
Do you guys have any questions on the prep work?
No.
No.
I was just working on the homework before this meeting.
You what?
I said I was just working on the homework.
Oh, okay.
Hopefully it'll clear up any questions.
This one's pretty short, so it didn't take too long.
Things to do.
Okay, here we go. All right.
Okay, cool.
Let's do this.
So find the margin of error for a 90% confidence interval when the standard deviation is 50 and the sample size is 25. Okay.
So I can't find my calculator right now, so.
That's okay, I have one.
You guys may have to
So it would just be the 50 divided by the square root of 25, right?
It's asking, so the margin of error, right?
Uh-huh.
And
I was just reading about this and I was trying to figure it out.
sorry. Okay. Yeah, it's the m equals equation, right? So it's just m.
Oh, we have to do that and then times, like in the applet, we have to type in 90%.
Yeah, and then we times it by that number.
Right.
Yeah.
So it would be 10 times 1.645.
4, 5, yep.
I got 16.45.
16.45. Okay.
It says round to 3 decimal places. Is that like it's just 4 or 5?
Yeah, I think they just keep that with all the questions.
Oh, okay.
Consistent.
Just making sure.
Yep. Okay, cool. Which of the following statements is true? Do you guys have any idea on this one?
I'm looking it up in the
Just
right now.
reading.
Yeah.
It says we will never know for sure if X is close to you.
Well, we're just looking for what the symbols mean, right?
So
mean is point estimate of. Yeah, so that's just the sample statistic, like the mean. So saying the sample statistic, and then U is the population parameter.
Are you on number 4 too?
Yeah.
Okay.
Is it like it says U is point estimator of X?
Right.
Sorry.
Okay. So is A the answer?
not sure.
I think
X is the mean.
Yeah, it's
O
the
is
sample
standard
statistic.
deviation.
Well, the X and the mu are both means. Just one's the sample statistic, one's population
Right.
parameter. So X is a point estimator. I think it's not the second or fourth one.
I think
it's the first or third one. Which way is it? X is a point estimator of mu, or mu is a point estimator of X.
if we go to 3.1 and lesson 10,
That's right.
there's a little chart, so it has x, and
That's
then
what I'm looking at, but it doesn't really explain which way.
I think it's C.
x is a point estimator of mu.
Yeah.
Well, that
I'm not
makes sense
completely
because
sure.
X is like the sample
Yeah,
and use the population.
right. Cool. I'm cool with that one.
Yeah, because it says the sample mean X will lie within 2 standard deviations of the population mean U. So I'd say that's kind of like a point estimator. But it's like just a sample of the overall. Okay, so Gina wants to construct a 95% confidence interval for GMAT scores. She knows standard deviation is 113. She collects a simple random sample of 64 and computes this. So the X sample mean is 526. Uses information for questions 5 through 8. So what is the lower limit of this confidence interval?
So we need to do it's 113 divided by the square root of 64. Yep.
Which is just
and then
8, right?
And then we times that by
1.96.
Yep.
I got 27.685.
Yep, that's what I got. And then so the lower limit is just 526 minus that number. Right?
Yeah, so I got 498.315.
Yep.
Do you guys round any of the numbers in between calculations?
We didn't have extra numbers for these ones.
Okay, so you got 498.315. Okay. So what is the upper limit? So is that you just add it to the 526?
Right.
Yeah.
Okay. So what is that?
Hold on. I got 553.685.
Five, 3. Okay, cool. She increased the sample size.
You guys, anything knows, but off the top of your head without like completely redoing the calculations?
It would decrease the confidence interval.
It would.
Yeah, because when you increase the population size, you change the standard deviation. So the standard deviation gets smaller. So if we just do 113 divided by the square root of 120, and then you multiply that by 1.96, yeah, it's 20 instead of 26.
Oh, yeah, that's right. Okay, cool.
So yeah, it would just decrease it.
To the width of the confidence interval if Gina changed it to a 99% confidence interval. So we just put in the 99% into the applet and just multiply it by that instead.
Yeah, so it would increase it.
So if you put a higher percent in, it gives you a bigger number.
Gives you a bigger z value.
Yeah.
Which, yeah.
So that would increase it. Bright Bulb Light Bulb Company is planning a study to assess the average life expectancy of their light bulbs. They know the standard deviation is 400 hours. They want a 95% confidence interval with a margin of error of 50 hours. What sample size do they need? Okay.
So that we just do the equation backwards.
Yeah.
Yeah.
Yeah, algebra.
So you just put in 95%.
It's
Okay.
1.96 times 50, right?
Well, yeah, basically you need to get square root of n by itself.
Hold
And
on.
then, you know, like you got to rewrite the equation. Oh my God.
Oh, I got it. It would be 400 divided by the square root of n equals 50. That's how you do it. And then so you
Equals 50. Where are you
do
getting 50?
algebra. Algebra is the margin of error that you want. Right?
Where are you getting 50?
It should equal 50, so it's...
I know. So in order to do the equation, you have to find n.
Right,
Yeah.
so it's
Sample size.
So it's 50 divided by 1.96.
You have to get n to the top square root. I mean, you can square both sides to get rid of the square root.
400 divided by second answer. And then...
Wait, did you multiply it by the number for the 95%? I might have made a mistake. I'm a little
Yeah, I did.
confused.
So the way that I don't know if you guys can see what I did on here. I don't know if it's turning up backwards. It's probably backwards.
Oh, yeah, that makes sense. Okay.
Yeah, so did you do like 1 divided by it to get it to the top?
So yeah, you just rearrange the equation. So then you just multiply each side by the square root of n, and then you move the 50 over, and so it's 1.96 times 400 divided by equals the square root of n, and then you just square each side.
Square each side, yeah.
To find n.
Okay.
So I got 245.86, but let me do the math again real quick. 1.96.
So 245.8, so it'd be 246. Just round to the nearest whole number.
Right.
Yeah, it'd be 246.
Awesome.
In her example, she didn't even round properly.
I know.
She says if you get 101.2, round to 102.
That's stupid.
I'm like, oh, okay. It's probably just an error, but.
Okay, let's see. Oh, there's only 12 questions. Okay. Mean salary of actuaries is mu, and the standard deviation is this. You're interested in to know if the mean salary for women actuaries is different from the population mean, but are not sure if it's higher or lower. You set up a hypothesis test with a level of significance at 0.05.
I get to do more math here.
Okay, what is the lower limit of this 95% confidence interval? So we just need to find the margin of error, which would be, so it's 36,730 divided by the square root of 36 times 1.96. Right?
Yeah, let me calculate it real quick.
And then subtract that from 100,000, right?
Mm-hmm.
So then what does that come to?
It gives us the nearest whole number is 99002. So 99,002. And then the upper limit.
Hold on.
Okay, did you get the upper limit?
Yeah, and the upper I got 122,998.
So 122,998, and then the lower limit was 99002.
Yeah. Did you get that same thing, Sarah?
No. No, I didn't.
Okay. What did you do?
Alright, so you take the 36,730 divided by the square root of 36, times that by 1.96,
Yep.
Mhm.
and then subtract that
From 100,000.
100,000 or
Not-
1,100?
1,100
Okay,
or 111,000.
that's what I did wrong.
Oh.
Let me look.
So Spencer, you did do it from our 111,000.
Yeah.
Okay, in that
Oh,
case,
okay.
I got 99001.53.
Yeah, so 99002. Sorry, I messed you up because I said the
That's okay.
100,000.
No worries. And what did you get for the upper?
It is 122,998.
2,
So there are 3 requirements that need to be checked when computing a confidence interval for a mean. They are: simple random sample is drawn from the population, X is normally distributed, 0 is known.
It has to be all the
It
above.
has to be all, yeah, that's a given. If there has to be 3 of them,
Yeah.
then there's only 3 choices.
Alright, so submit.
Yep.
Okay.
Oh gosh.
Oh yeah, we got 100%.
Way to go, guys.
Finally, we got 100. There we go.
I know.
Yeah, it's been a long time.
Okay. Are you guys good
Time
to
to go.
just meet on Wednesday, same time?
Yeah,
At 8, yes.
Okay.
that'd be good.
Cool.
Okay, see ya.
Yeah.